Okay, so now let's look at these. We'll go around the room, starting with you, Kristen.
I said Mg2 plus aqueous plus CO.
Okay, is the CO aqueous? Yeah, at this point, it's no longer floating in solution because it's cobalt metal, so it sinks down to the bottom. It's a solid. When they're ions, they're floating around aqueous. Okay, how about the next one, Allie?
Chromium 2 aqueous plus 2. And tin solid.
Brady? And the last one, Reagan? No reaction. So those are pretty straightforward. Now, we look at these and we can just kind of plug and chug from the activity series. But I want you to start thinking about the chemistry that's going on. This is redox chemistry. So the magnesium is going from magnesium solid to magnesium 2 plus. What's happening to magnesium here? In terms of oxidation reduction chemistry. It's losing 2 electrons, so it is getting oxidized. It's the reducing agent. What's happening to cobalt? It's gaining electrons, so it's being reduced. So when we look at the activity series and we think about the activity of metals and we think about redox, what statement can you make? What statement can you make comparing or relating the activity of something to its oxidation or reduction capacity? Perfect. The more active the element, the more likely it is to be oxidized, or the easier it is to oxidize. Now, when I think about this, think about rust on your car. Okay, rust is iron 3 oxide. So you leave the iron out there in your car, it gets where the paint scrapes off, and you start to get rust. Okay, rust looks nasty. Aluminum foil. You buy it on sale and you don't use it for a while. When you open it, it looks kind of cloudy. It's not shiny anymore. There's like a white film. That's aluminum oxide. Okay, think of copper. Nice shiny penny, copper on the outside. A few years later, all brown and nasty. That's copper oxide. Okay, so when you oxidize things and make the oxides, they don't look so nice, right? But that's because they were more active. So now let's look at some other things that can happen that is also redox chemistry, other types of redox chemistry. We can have a reaction with molecular oxygen. Oxygen is an oxidizer. And combustion is a very common reaction with oxygen. It produces heat and light. So for our purposes in this class, I will expect that from this time forward, you will be able to understand complete combustion and you can write and balance an equation for combustion. In complete combustion, we start with our burnable material, in this case methane, a hydrocarbon. We add oxygen and we make carbon dioxide and water. So anytime we have plenty of oxygen, we get complete combustion and we write an equation that makes carbon dioxide and water. And then we balance that equation. So in this case, I need 2 oxygens and I make 2 waters. Sometimes we don't have enough oxygen. So if I have a limited amount of oxygen, then I don't make carbon dioxide. I make carbon monoxide. Okay, carbon monoxide and water. And again, we still need to balance this equation. It balances differently because I don't have as much oxygen. So I use 1 1/2 or 3/2 of oxygen to make 1 carbon monoxide and 2 waters. Why do you not want carbon monoxide in your furnace, in your house, or in your car? Yeah, you will die. Does carbon monoxide kill you? Not exactly.
Take away your oxygen?
Yes, you actually die from lack of oxygen. The carbon monoxide doesn't kill you, the lack of oxygen does. And what it does, you know how the oxygen goes in your lungs, then it jumps on the little heme and rides around in your bloodstream till it gets to the place where you need it and it releases? Oh, okay, that's a simplified version for a chemist, right? So what happens is the oxygen jumps onto that heme, rides around, and it hops off. The carbon monoxide jumps onto the heme, rides around and stays there. Just keeps riding around, rides around, and it uses up that little transport site. So as you fill up all those transport sites with carbon monoxide, no oxygen can get on there, and you die from lack of oxygen.
No, you just literally go to sleep.
I don't know. I know that it's characteristic because your face gets really bright red from it, but I don't know what it feels like. I've never experienced it. And when people do, they usually are very sleepy, and I don't think that...
When we did training for EMTs, they said normally your pets would go first, and if your pet started dying, then there was something wrong with, there was probably carbon monoxide if your animal started to die.
Oh, really?
Birds and like
And canaries in the mines, yeah. Yeah, and I don't know if it was carbon monoxide, but it was it was for checking to see if there was enough oxygen. They would take a canary, drop it down in the, what? Yeah, that's how they would check. And if the bird died, they didn't go in. Yeah, it was technology of the time. So, very limited oxygen. If you have so limited oxygen, you can actually just produce carbon, like soot, and water. But for our purposes, we're going to deal with situations where we have adequate oxygen. And another thing just to briefly mention is what happens when we burn things that contain sulfur. You know, environmentally in Michigan, this has been an issue about burning high sulfur coal because it makes sulfur dioxide gas. So when you burn compounds that have sulfur in them, you make carbon dioxide plus water plus sulfur dioxide. And again, we balance our equation. We need 9/2 oxygen here. We get 2 carbon dioxide, 3 water, and SO2 gas. But the one we're interested in for the purposes of this class is to be able to write equations for complete combustion, where we add oxygen and we produce carbon dioxide and water.
How did you balance that?
Which one? This one?
The last one.
9/2 of oxygen, 2 carbon dioxides, 3 waters, 1 SO2.